Okay, let's go ahead and start Chapter 8. Chapter 8 is all about similar figures, and similar figures basically just means two polygons or shapes that are the same shape but different sizes. Like they look exactly the same, one's bigger, one's smaller. And in a lot of what we do with similar figures, we always use proportions because everything in the two similar figures will be proportional. So we use proportions, we set up and solve them lots and lots of times in this chapter. So first thing that we are going to do for this unit is we're just going to review how to solve proportions. Okay, so if you're looking here, proportion basically means it's a ratio equals a ratio or a fraction equals a fraction, things like that. And to do it, we use the process that's called the cross product. Okay, which means you're going to multiply across and set them equal to each other pretty much. So that means we are going to look diagonally across, and product means multiply. So we're going to multiply those two things together. The gray multiplied together, 8 times x is 8x. 5 times 2 is 10. And as I'm looking at this answer, I'm noticing the directions say round to the nearest hundredth if necessary. Hundredth is 2 places past the decimal. Okay, so if we wanted x by itself, we would divide by 8, and 10 divided by 8 is 1.25. We don't need to round for that at all because hundredths is 2 places past. Okay, and then it gets a little bit more difficult. We're going to put algebraic expressions in there instead of just x. We solve it in the same manner. Okay, we just use our cross product. The 10 times 5 is 50. And then we have 8, and we are going to multiply it by x plus 10. Notice I put that in parentheses to use the distributive property. So we would have 50 equals 8x plus 80. And now we're back to just a two-step equation that we've done lots of times. So let's go ahead and subtract 80 from both sides. And we get negative 30 equals 8x. And just divide by 8. And we get negative 3.75. Again, that ends at negative 3.75, so there's no rounding to be done. Okay, we're just going to add, now we have variables in two different spots. Still doing that same process, right? We're going to use our cross product. 7 times n is 7n, and then 8 times n plus 6. We're going to use that distributive property, 8n plus 48, and I am going to subtract 8n from both sides. Negative 1n equals 48. I do not want negative 1n, I want n, so I'm going to divide both sides by negative 1, and I get n equals negative 48. Okay, last one. Okay, we're going to go ahead, cross product, 3 times x plus 3, and 4 times x minus 7. This time we have the distributive property on both sides of the equation. So I need to go ahead and distribute and get 3x plus 9 and 4x minus 28. I'm going to subtract that 3x from both sides to get my x's all on one side. And then I'm going to add 28 to both sides, and I get x equals 37. Okay, so we will be solving proportions a lot in this unit, so just let's make sure that we know how to do that. Okay, so a little bit more, not just proportions, because that's a little more algebra, but actually some vocabulary and things like that for this unit. We are going to talk about similarity, and if two polygons are similar, that basically means, I said this a minute ago, that they are the same shape, but different sizes. Okay, it's kind of like on your phone. When you zoom in, you zoom out. It doesn't change the shape of the words or the shape that or the picture that's on your phone. It just makes it bigger or smaller. And we did a little bit something similar to this with dilations that went back in the first semester. And for similarity, we use just a little squiggle mark. If you remember, last semester we used, that meant congruent. Basically, similar, all we're going to do is just going to get rid of that equal sign underneath, and we're just going to have the squiggle, pretty much. So a similarity statement, kind of like in the last statement of our proofs last semester, we would have a congruence statement that said triangle is congruent to another triangle. A similarity statement just states that the two triangles or whatever the polygons happen to be are similar to each other. And the thing we have to make sure that we do with that is to make sure the corresponding angles are in the same order. So if you notice, X has one tick mark in it, Q also has one tick mark in it, which means those are corresponding. So when we list them, they have to be in the same spot. And then we have Y has two little tick marks, P has two little tick marks, and then Z and R. So when we go to list these out in our similarity statement, if I say X, Y, Z is similar, I have to say Q, P, R. Okay, that's not the only order. We could have went Z, Y, X. If I go Z, Y, X is similar. Z means that first, if I put Z first, green and green has to be R, and then Y are the blues, so then I would have P, and then my pinks are X and Q. So there's a lot of different ways that you can write it, just as long as those corresponding parts are in the same spot. So if you notice again, oops, wrong one. So we had pink was our X and Q, they are in the same spot. Blue, blue, and green, and green. Okay, and it's the same thing down below, just in different order, but they all correspond. Okay, so down here, again, similarity statement. They're kind of in, like, notice the A and the P are already blue, the B and the Q are already pink, things like that. So we would, if I was going to go A, B, C, D, oops, is similar. Okay, we'll just put similar to, have to go in that same order. A is first, which is blue, so it'd have to be P, then Q, then R, then S. Okay, so that is a similarity statement. There's no calculating, it is just making sure that your letters are written in the correct order. Okay, and then, you know, we're going to add a little bit more to that, not just the vocabulary, but geometrically speaking, we can say that all pairs of corresponding angles are equal to each other. Okay, angles don't get bigger or smaller when you zoom in and zoom out. Side lengths get bigger and smaller. Angles do not. Okay, side lengths are proportional, so they have the same scale factor. Okay, well, what is a scale factor? A scale factor is just the ratio, or a ratio is just a fancy word for a fraction that compares corresponding sides of similar triangles. And we use the variable K to represent the scale factor. Basically, the scale factor tells you how much bigger or smaller your shape is going to get. Okay, kind of like a dilation, if you remember that. Okay, so all we're going to do on these first couple of examples here is identify or state what the scale factor actually is. So if we were going to identify corresponding sides, this side corresponds to this side. If you notice the greens that I have marked, the one on the left has a 30, the quadrilateral on the right doesn't have anything on it. Not very helpful. And then if I said this one and this one, the two blues, well, yeah, those are corresponding, but that's not helpful for us to write a fraction comparing the two because there's nothing, we don't know the number for the blue on the left. And then if we said 20, and over here, again, the pinks are not helpful because they have a 20, but I don't have anything on the other side. So if I look down here, I've got 30 and 24. So when I say useful, that means find the pair that has a number on both of them for that pair of corresponding sides, okay? And all we are going to do is we are going to write that pair of corresponding sides as a fraction. So we are going to write 30 over 24. Okay, and everything is going to be a simplified fraction. If you are not very good at simplifying fractions in your head, your calculator will do it for you. So if in your calculator, here's a quick little lesson on how to simplify a fraction. 30 over 24 means 30 divided by 24. So if you put 30 divided by 24 into your calculator, it's going to give you 1.25. Okay, we do not ever write our scale factors as decimals in this unit, okay? Which means if we want that as a fraction, we are going to hit the math button. Okay, so we hit the math button, and it brings up a list. The first thing says fraction, so we are going to actually hit 1 for fraction. Okay, so if we hit 1, and then it's just basically on your screen says turn your answer into a fraction, and then we are going to hit enter again. And when you hit enter again, now it is a fraction, 5 over 4. Okay, so again, if you're good at simplifying fractions, great. We do not want decimals. We want everything to be in the form of a fraction. Okay, so let's look at our second one here. Let's do this one a little bit quicker. We can look at the picture and say, oh, I see that this and this both have numbers on the corresponding sides, right? So I am just going to write those two corresponding sides as a fraction. And then 5 goes evenly into both of those, which would be 6 over 5. Or you can put it into your calculator if it would help. Okay? And then the last thing is that we are going to be given two similar figures, okay? And we are just going to write and solve a proportion to find x. Okay, so I have, here's a pair of corresponding sides in yellow, and here is a pair of corresponding sides in green. When I go to write my proportion, I am just going to go yellow to yellow equals green to green. Okay, so I'm going to go yellow to yellow equals green to green. And if you notice, if I put x plus 6 on the top here, and 15 on the bottom here, then I have to put the 20, which is the one on the left on the top, and the 25 on the bottom. Okay, so if I go like left on top, right on the bottom, left on top, right on the bottom, kind of a thing, and then we are just going to go ahead and solve our equation just like we have before with our cross product, and 20 times 15 is going to be 300. And then 25 times x plus 6. We're going to distribute that. 300 equals 25x plus 150. If I subtract 150 from both sides, I get 150 equals 25x. And if I divide by 25, I get x equals 6. Okay. Now, right up here, this is not the only correct way to write out the proportion. You just have to make sure that corresponding parts are in the same positions. So if there's another way that you found that makes more sense for you to write out the proportions, that's fine too. Okay, so now we're going to go over to the second one. If you notice, we have some extra information on here, okay, where we have, here is 20, and here is its side that corresponds to it. Here is 30, and here is the side that corresponds to it. That 40 is not helpful. It's just there to confuse you. So let's get rid of that 40 so we're not confused. Okay, and then we are just going to set up our proportion. I'm going to go pink over pink, so I'm going to go 20 over 24. And then we are going to go blue over blue, so we are going to go 30 over 3x plus 6. And then we are just going to do that cross product once again, diagonally. And 24 times 30 is 720. And then 20 times 3x plus 6. So we're going to do our distributive property. We're going to get 60x plus 120. If we subtract 120 from both sides, we get 600. Divide by 60, we get x equals 10. Okay, so again, everything that we do is just going to be setting up and solving a proportion. Okay. Okay, you have homework is going to be to start your similar figures class kick. I think you do the first 5 or 6 slides and then you'll hit a stop sign where you can stop. So good luck.